Okay, so in this video, we're going to look at what the derivative of a to the x is. Before I get into that exactly, what I'd like to do is review some of the log rules. So the first log rule we have is if you take an exponent and raise it to the log base a of x, it becomes x. Okay, and if you do it the reverse, if you take the log base a of a to the x, that's also x. Same thing works if you take exponential e. So if you take e to the ln of x, that'll give you x, or the log base of e to the x also gives you x. Okay, that's going to come into some of the work we're going to do today. So let's look at another form of what a to the x can equal. All right, so if we start off with e to the ln of a, we really know that that means that that's e to the log of e to the a, okay, which is this up here, just a base of a instead of a base of e instead of a base of a, okay, and we know that that's going to equal a, okay, or we could use this rule right here. So now let's change this back to e to the ln of a. E to the ln of a is equal to a. Now, if I take and raise each of these sides to the x power, okay, if I raise both of these to the x power, I'm going to result in e. I'm going to bring the x out front, so I got e to the x to the ln of a is going to equal a to the x. Okay, this is going to be helpful for us in the proof that we do. Okay, because when I go to take the derivative of a to the x, I don't know how to take that, but I do know how to take the derivative of this left side. So I'm going to take the derivative of e to the x to the ln of a. Now the last video we just did, we did a whole video on how to take the derivative of e to the u, or e to the x. So that's what we're going to apply here. So when I go to take the derivative of this, I'm going to say, okay, well, it's e to the x to the ln of a. But then I'm going to need to take the derivative of the exponent. Okay, now this is going to be a product rule. So I'm going to get e to the x to the ln of a times, product rule says this is x times the derivative of ln of a, plus the ln of a, ln of a, ln of a, times the derivative of x, which is 1. Okay, so when I clean this up, I get e to the x to the ln of a times, now the derivative of any constant is just 0. So that's going to give me 0 plus the ln of a. So the derivative is going to be e to the x to the ln of a times the ln of a. Now if we go back over to here, e to the x to the ln of a is equal to a to the x. So that means I can substitute it back in and just say it's a to the x times the ln of a. Okay, so in summary here, we can say that if we take the derivative of any number that is not e and is not 1 and raise it to the u power, that's going to be the same as taking a to the u. Then we'll take the natural log of a, but you always have to remember the chain rule, so you have to take the derivative of the exponent or the composition function. Okay, so in the next example, we're going to apply this new derivative that we just found right here. Okay, so we're going to use this in our next formula. Okay, so here's the question: at what point on the graph of the function y equals 2t minus 3 does the tangent have a slope of 21? Okay, so we got to dive in and take the derivative of this. Y equals 2 to the t minus 3. So when I take the derivative, I'm going to get dy dt is going to equal, okay, so I've got to take the derivative of this whole thing. So I'm going to take the derivative of 2 to the t, and that's going to be the last rule we just went over. I'm going to take the derivative of 3, which is just 0. Okay, so when I take the derivative of 2 to the t, the rule says if I'm taking the derivative of a number to the u power, then that's a to the u to the ln of u. Okay, and then I can say du dx. All right, so in this case, if I take the derivative of 2t, that's going to give me 2t to the ln of times the ln of 2. Okay. Up here, the formula should have been an a right here. Sorry. All right, and then the derivative of this is 0. All right, so that's what your derivative equals. So now it's going to say, let's let the derivative equal 21. So I'm going to say 21 is equal to 2 to the t to the ln of 2. Okay, so now I'm going to solve for t. So to do that, I'm going to divide both sides by the ln of 2 and divide by the ln of 2. So that's going to give me that 2 to the t equals 21 divided by the ln of 2. All right, now to get t by itself, I'm going to take the natural log of both sides. Is 21 over the ln of 2. Okay, so this cleans up nicely. The t can come out front, and then I can say t times the ln of 2 is going to equal. All right, so this is going to be where subtraction rules come in. I could say that this is the ln of 21 minus the ln of the ln of 2. Okay, and now I can divide both sides by the ln of 2. So this and this will cancel, but I'm going to divide over here by the ln of 2. So t is going to be equal to the exact answer of the ln of 21 minus the ln of 2, all divided by the natural log of 2. Okay, and that's going to give me my exact answer. If you plug that into a calculator, I plugged it in and I get approximately 4.921. And then if you plug t in for y right here into this function right here, so 2 to the 4.921 minus 3, you're going to get a value of 27.3. So the answer to this problem is at what point on the graph, so it wants your coordinate, so you'd say the answer is at 4.921, 27.3 is the answer to the question, and that is where the slope is equal to 21.